In the previous chapter, we looked at atoms and how their structure determines their properties. We looked at only individual elements. In chapter 7, we are going to look at how elements combine to form compounds. Compounds are everywhere in the world and are made by chemically combining two or more elements, and those two or more elements are always combined in fixed proportions. The compounds that result are quite different than the original elements. For example, consider sodium plus chlorine. Sodium is a soft metal and it reacts vigorously with water. Chlorine is a gas and it is very, very toxic. Together, they combine to make sodium chloride, which is common table salt. Another example I want to consider is just looking at the compound H2O. You are familiar with this as the formula for water. This shows perfectly how elements always combine in fixed proportions to make a compound. There will always be 2 hydrogen atoms for every 1 oxygen atom in a molecule of water. Next, we are going to be looking at the formation of ions. Atomic theory suggests that atoms bond together based on the arrangement of their electrons. The protons and the neutrons are not involved. Therefore, the nucleus is not involved in the formation of compounds. The Bohr diagram, then, with its electrons, will be a useful tool for studying how compounds form. So atoms bond together based on the arrangement of their electrons. Atoms that are neutral have the same number of protons and electrons. So neutral atoms have equal numbers of protons and electrons. That is to say, they have equal numbers of positive and negative charges. That's how they are neutral. Atoms will tend to gain or lose electrons so that they resemble their nearest noble gas. They gain or lose electrons to attain complete outer orbitals. If you study the Bohr diagrams for noble gases, they all have complete outer orbitals. To look at how elements gain or lose electrons, let's consider the example of oxygen. I'm just going to draw this over here. If we look at the Bohr diagram for oxygen, it has 2 electrons in its inner shell. I'm not even going to show the nucleus here. Oxygen has an atomic number of 8, so we need 8 electrons in total. So I'm going to put, so we have 2, 3, 4, 5, 6, 7, 8. This atom has 8 electrons in total, but its second shell, its outer shell, only has 6. It wants to gain 2 more electrons so that it has a full outer shell. This will be the ion for oxygen. Having gained 2 electrons, because electrons have a negative charge, it now has an overall negative charge of 2 negative. This is the ion of oxygen. Because we will be dealing so much with just the outer shell of Bohr diagrams, it is useful to learn some terminology. The outer electron shell of an atom is called its valence shell. Likewise, outer shell electrons are called valence electrons. Only the valence electrons are involved in bonding. When an atom completes its valence shell, it becomes charged. And it does this by either gaining or losing electrons. Atoms that are charged are called ions. Positive ions, also known as cations, are positively charged because they have lost electrons. So positive ions lose electrons. Negative ions, which are also called anions, have gained electrons. Next, we're going to look at some examples of atoms, and then we'll look at how they lose or gain electrons and the ions that they form. In each of these skeletons for Bohr diagrams, I have written the symbol as well as the atomic number. So the atomic number for fluorine is 9, meaning that fluorine has 9 protons, and that a neutral atom will also have 9 electrons. So I can put 2 electrons in the first shell, 7 left. I'm going to put those into the second shell. So we have 1, 2, 3, 4, 5, 6, 7. When fluorine is going to become an ion, it wants to complete its outer shell. An atom will always do what is easiest. So fluorine can either lose 7 electrons or it can gain 1. It'll be easier to gain 1. So the ion of fluorine will show 1 extra electron in the outer shell so that it is full. We need to indicate the charge on the ion, so we put it in parentheses and write -1. The atom gains 1 electron to become the ion. Next, we will look at neon. Neon has an atomic number of 10, meaning that it has 10 protons, and that the neutral atom also has 10 electrons. Putting these onto the Bohr diagram, you can quickly see that this means that it already has a full outer shell. Neon is an example of a noble gas. Noble gases do not form ions and are typically not involved in chemical reactions. This is because they already have a complete outer shell, and they do not want to gain or lose any more electrons. So I'm just going to draw neon the same way. Moving up one more in order, increasing atomic number, we come to sodium. Sodium has an atomic number of 11. So it will have complete first 2 shells. I'm going to put 8 in this shell. And we'll have 1 lone electron in the 3rd orbital. When neon forms, or sodium rather, forms an ion, it will lose 1 electron. It is much easier to lose that 1 electron than to gain 7. So the sodium ion will have its inner 10 electrons and have lost that outer electron completely. Because of this, it has 1 additional positive charge compared to its negative charges, and we write the charge here as +1. Scrolling down to symbols for ions, it's really important to note that ionic charges must be included when writing the symbols for ionic compounds or ionic atoms. For example, the symbol for sodium is Na. The symbol for the ion is Na+. This indicates that sodium loses an electron to become an ion. An example of a atom that becomes a negative ion is chlorine. The ion is Cl negative, indicating that sodium or chlorine gains an electron. It's really important to write the charge on the ions because the charge is how we distinguish the ion from the atom. The ion may only be different from the atom by just an electron or two, but it can be very different in properties from that of the atom. Lastly, we will be looking at the transferring of electrons. We already know that atoms are more stable with complete outer electron orbitals. Metals, which are trying to lose electrons, can transfer electrons to nonmetals. So they will give their electrons away to nonmetals, which happen to be trying to gain electrons, in order to achieve complete outer orbitals. As a result, both atoms involved become ions. When ions form, the nucleus does not change. Nothing happens to the protons and the neutrons. It is only the electrons that are involved. Let's look first at the atoms for sodium and chlorine. So sodium has an atomic number of 11. So I'm going to draw the Bohr model for sodium with its 11 electrons, meaning that it'll have 2 in the first shell, 8 in the second shell, and then just one lone electron, which I'm going to draw over here in the outer shell. Chlorine is 17. So first 2 shells are full. That'll bring us to 10. Draw this in really quick. And then in its third shell, we need to put 7 more. So really it is just missing 1. This works out nicely. Sodium has 1 extra. Chlorine is looking to gain 1. So in the next diagram, I'm going to show the same 2 atoms. So I'm going to draw this in really quickly. And then I'm going to show the transfer. So here we had sodium. Here we have chlorine. Chlorine having 17. We'll take a bit more here to draw. This is the transferring. And this lone electron will be literally transferred from sodium to chlorine. The result is a sodium atom, which has lost 1 electron to gain a full outer shell. So this now has a charge of +1. And a chlorine atom, which has gained 1 electron. So I'm going to draw this in here. And this time it will have gained 1 electron to have a complete outer shell. So it now has a charge of 1 negative. Your homework challenge at the bottom of this page is to draw the Bohr diagrams for 2 different elements. And I'm going to choose magnesium and fluorine, a metal and a nonmetal, and then to show the transfer of electrons and the ions that result.